So if I am connecting load as short load, we are having impedance ZL, load impedance as 0, thereby we will get reflection coefficient as -1. It indicates the incident wave and reflected wave is 180 degree out of phase, but magnitude remains same. So thereby we will get S value as infinity. Thereby in practical case we are having V maximum value and V minimum value. So what is incident wave, what is reflected wave is demonstrated here. So consider the solid line as incident wave and the reflected wave is dotted line. So from this we indicate that these two are of more or less of same magnitude, but they are 180 degree out of phase. 180 degree out of phase. So these two signals are present in the transmission line or this waveguide. So for mathematical purpose, these two waves gets added up. So added up means, so consider these two incident wave and reflected wave gets added up. We will get standing wave. Standing wave is nothing but combination of incident wave and reflected wave. So this standing wave I am having maximum value and minimum value. How you get maximum of standing wave is adding maximum of incident wave and maximum of reflected wave. So we will get V maximum or maxima, and minimum of standing wave is obtained by adding minimum of incident wave and minimum of reflected wave. So we will get V minimum. So in this experiment we are going to measure this V maximum and V minimum of a short load. This will indirectly we will get what is the standing wave ratio obtained from the load what we are connecting. So we will go to the experiment. So already I have told about the signal generator, this combo of this power supply and signal generator, this isolator and slide screw tuner, and then we have to connect the load what we have to measure. So this slide screw tuner is compatible to measure V maximum and V minimum. So this slide screw tuner is looking like the internal setup will be like this. So consider an wave is transmitted or incident wave and reflected wave is in the same waveguide. So I am drawn as a combination of two waves as standing wave. So inside this waveguide I will have two waves, incident wave and reflected wave. So for mathematically analyzing purpose, I am adding these two waves as standing wave. So from this onwards, we will see this internal to this waveguide, we are having one wave, that is a standing wave. This standing wave has maximum amplitude and a minimum amplitude. So this maximum amplitude we call it as V maxima and minimum amplitude we call it as V minima. So for the experiment, first I am connecting open load. Open load is nothing but I just leave it as it is. So R acts as some load, that is a open impedance. So I will get some amplitude. So what I am doing is consider this outer body indicates a waveguide and the dotted line is nothing but a slide screw tuner. I am moving this tuner. So this is the waveguide. I am moving this tuner. So what will doing this tuner, this movable carriage is run over the waveguide. So internal to the waveguide is a standing wave. So indirectly this carriage moves over the waveforms. Thereby it can meet maxima and minima. So thereby we can measure what is the maxima, V maxima and V minima. So in the experiment what we are doing, from the initial setup I am varying the carriage position, thereby the amplitude of the standing wave varies in the CRO since I am moving the carriage over the waveform. Thereby the sinusoidal signal looks like square waveform because in the detector, this one is detector, it gets demodulated as sine wave is converted into square wave. This is the detector or demodulator for converting sine wave to square wave. So sine wave having maximum amplitude indicates maximum square wave. So by moving over this waveguide, I will get maxima amplitude and minima amplitude. So what I am doing, from the initial position, from the right side, I am moving towards left side. So thereby, by moving from right to left, the voltage varies on the CRO. So first note down maximum voltage in the CRO by varying the carriage from right to left. So for this open load, this will be the V maxima voltage. So you are able to measure this maximum voltage. That is how to measure. So measure how many boxes it is able to cover. So 1, 2, 3, it's 3.4. 3.4 boxes is covered, and it should be multiplied with channel 2 voltage. So channel 2 is 10 millivolt. I am connected it with channel 2, so thereby 10 millivolt. I have to note it this V maximum value. 3.4 into 10 millivolt gives 34 millivolt. Similarly, this is the V maximum value, and further varying, I will get surely minimum sinusoidal signal. So this sinusoidal signal maps to square wave. So what is the minimum square wave amplitude? So this will be the minimum square wave amplitude. So note down. So at least it will be 1.1 boxes multiplied with 10 millivolt. So thereby 11 millivolt for V minimum. So V maximum is 34 millivolt, V minimum is 11 millivolt. On division we will get it as S value. S is nothing but V max by V minimum. We will get 34 by 11. More or less it will be equal to 3. Similarly, this is how to measure standing wave ratio. We are measuring V maximum in CRO and V minimum in CRO, and manual division we will get S value. From that we can able to find reflection coefficient. From reflection coefficient we can able to find load impedance indirectly. And also another method to measure load impedance is, so we have to measure the minima position, minimum. So using this carriage, like what you have studied in physics, vernier caliper, it is also a vernier scale. So you have to find at least two minima by moving this carriage from right to left. So I am adjusting this carriage from right to left. First find out first minimum voltage in this CRO. So this is the minimum CRO voltage. This is the V minimum, what you have as 11 millivolt. So here you don't see just note down what is V minimum, and also you have to note what is the position of carriage, vernier scale. So in vernier scale we are having vernier reading as well as main scale reading. What is the meeting value of 0 in the vernier with respect to main scale? So 0 meets with, it will be 9.6. So note down D1 as 9.6 centimeter. It is a centimeter scale. So 9.6 centimeter is nothing but minima, first minima position of that standing wave, and I need to find second minima position also. So adjust this carriage towards left. During this case I will get one maximum, so no need of maxima, and find minima. So this will be the minimum, what I am seeing, minimum voltage what I am seeing in CRO, and this is the minimum voltage. So first minima, after varying carriage I will get maxima and then minima. So note down this second minima position where 0 coincides with main scale is nothing but 12.2 centimeter. So I am repeating. So this will be D2, second minima position as D2, the first minima position 9.6 as D1. Okay, take down this reading, these two readings is essential for calculating load impedance. So I am repeating what happening in the waveform. So I am moving the carriage from right to left. So what it happens, the amplitude of square wave gets varies. So varying, so it will attain maximum after minimum. So this is the minimum amplitude. So you have to measure D1 in the vernier in this slide skew tuner as around 9.6. And then what I am doing, further vary the slide skew tuner, thereby the waveform gets increases and it will reach maximum and it starts to decrease, it reaches minimum, thereby measure this D2, it's around 12.1. So this will be D2 or minima, second minima position, first one is first minima position. So take down this reading for open circuited load. Similarly, connect matched load here as a load. So measure V maxima and V minima in CRO from the right end, move towards left. So I will find maxima. After, so note down the V maximum voltage and then further moving towards left, I will get V minimum. So for ideal case, V maxima and V minima to be same for matched load. Since S value for matched load is 1, reflection coefficient to be 0. So for practical case, some deviation from V maximum and V minimum case. So for finding D1 and D2, D1, D2 is nothing but minima positions. So you have to note down in the slide skew tuner carriage positions. Similarly, you have to repeat with some another load. This is the horn antenna. This is the unknown load. You have to connect this as load. Similarly, repeat the same procedure. Find the V maximum, V minimum, D1, D2. These 4 readings are essential for this calculation. So after that, we are proceed to mathematical calculation using formulas to calculate unknown impedance. Thank you.